free response question for the day to practice with me. So in this question, you're given a table of values, and T is in hours and B at T is miles per hour. So it's important to know that what you're looking at there is a rate. Brandon and Chloe ride their bikes for 4 hours along a flat straight road. Brandon's velocity and miles per hour at time T is given by a differentiable function. So if something's differentiable, that means we know it's continuous, and you can take the derivative everywhere. Now, values of B at T for selected times T are given in the table above. So this up here is Brandon. Down here is Chloe in terms of her velocity from 0 to 2 and then 2 to 4. So let's start answering the question and go back if we need to. How many miles did Chloe travel from 0 to 2? So if we're given a rate, and again, that's Chloe's velocity, and I want to know the amount of miles traveled, all I need to do is integrate what I'm doing. So from 0 to 2, could you integrate? From 0 to 2. Now be careful if this was in the middle of the piecewise, but it's not. 0 to 2 is only 1. That's TE, and then to the exponent 4 minus t squared dt. So there's the setup. The next step would be to understand what is the hook involved there. So the derivative of 4 negative t squared, or it's just negative 2t. That's the derivative. So the derivative of negative t squared is negative 2t. What was it before? What did it become? It needs a negative, a half in front. So then this, the hook, goes away, and then what's the rule for ease? You just copy it. And then I need to substitute in. So first I substitute in 2. So I go negative 1/2. E 4 minus, what is it, 2 squared, minus negative 1/2 E4 minus 0 squared. And you don't have to do anything else. Just make sure that's in units. And the units here is in miles. So how many miles did Chloe travel? So Chloe traveled that many miles. From when t equals 0 to t equals 2 hours. All right. Part B. At time t equals 3, Chloe's speed, is it increasing or decreasing? So is the speed increasing or decreasing? And give a reason for your answer. So first of all, I'm looking at Chloe, and it's at t equals 3. So which piece is that? That the top piece or the bottom piece when t equals 3? So I'm going to write that down. Now, what I care about is only at 3. Now, if I just plug in 3 into this, it would just give me the velocity. So first of all, I just want to get a sense of the velocity. So this is 9, take away 9. So this answer is so you plugged in 3, negative 9 and negative 9 is negative 18 and 12. That's negative 6 when you plug it in. Now, that doesn't tell me it yet. That just tells me that she's slowing down, but it doesn't tell me if it's increasing or decreasing until you find the acceleration. When the signs match, the velocity and acceleration, when the signs match is when it's increasing or decreasing. So I need to take the derivative. So just the bottom piece, take the derivative. That's negative 3 and negative 2t. And again, with the bottom piece, I'm going to plug in 3. And now again, I'm looking for the answer. So that answer is negative 9. So is it increasing or decreasing? And because the signs match, so because both velocity and acceleration are negative, the speed is increasing. So it's increasing at t equals 3 hours. All right, turn the page. See? Is there a time t from 0 to 4 at which Brandon's acceleration is equal to 2.5 miles per hour, and then justify your answer? So all I'm given for Brandon is this table of values. So I'm not given an equation. So at between 0 and 4, 2.5 acceleration, that's the derivative here. Now, the only thing I can find with this, the way it looks right now, is the average rate of change from 0 to 4. So that's what I'm going to start with. From 0 to 4, what was this average rate of change? And so to do that, we're going to plug in. So it's b at 4 minus b at 0, and then 4 take away 0. Just find the slope. So b at 4 is 11. At 0, it's 1. And then, so when you do the work, 11 take away 1, 4 take away 0, that's 10 over 4. That's 5 over 2, or 2.5. Now, notice that's the exact number that's given in the question, 2.5 miles per hour per hour. So there's a theorem here. What does the mean value theorem say? So it says this, the average rate of change must equal the instantaneous rate of change at least one time between 0 and 4 since b at t is a differentiable and continuous function. So the question is there a time? And the answer is yes. The mean value theorem states that the average rate of change, which is 2.5, must equal the instantaneous rate of change at least one time between 0 and 4, since b at t is a differentiable and continuous function, which is given right in the prompt at the beginning. Part D, last one. Is there a time t between 0 and 2 in which Brandon's velocity, that's the table of values, is equal to Chloe's velocity, that's the equation, and then justify your answer? So when you look at Brandon's velocity, his initial velocity, the answer is 1. When you look at Chloe's initial velocity, and you plug in, zero times anything is 0. So what you notice is that Brandon's velocity is greater than Chloe's at the beginning. Then at the end, at the very end, what is Brandon's velocity? At 4 is 11. And then Chloe's, at the very end, was hers, 12 minus 3 times 4 minus 4 squared. Oh, no, sorry, it's not 4, but 2. I plugged in the wrong one. So at 2, what is the one? So at 2, it is 1.5. And for 2, you plug it into the top one. So if you plug it into the top one, you'd have 2e 4 minus 2 squared. So 4 take away 4 is 0, e to the 0 is 1, and then this would actually just become 2. So what do you notice here is that Brandon's velocity was greater, then Brandon's velocity is less, over from 0 to 2. So since b at 0 is greater than c at 0 at t equals 0, and b at 2 is less than c at 2 at t equals 2, now there's a theorem here, and it's called the intermediate value theorem. That's sometimes called IVT. There must be one time from t equals 0 to t equals 2, they have the same velocity. See, if one is greater and then it switches and the other one's greater, there must be a time that at one point they're the same velocity before they switch, and one has a greater velocity than the other. And that is called the intermediate value theorem when you look through it and do that. Anyway, great job doing a free response question with me, practicing with me, keeping your skills up, keeping your attitude as best as it can be. I'm on your side. Mr. G Math, over and out.